In this video, I'll walk through a number of examples of percent change. Now, percent change is such a useful calculation to be able to do. And so you want to make sure not only can you do these examples, but do you understand them? But when we're looking for the percent change, we're going to use this formula that the percent of change, so how much has something increased or decreased? What percentage has it increased or decreased? And we're going to use this formula that it's the amount of change divided by the original amount. Now, the reason that we're concerned with a percent change is this. If you have, let's say, something that weighs a great deal. Let's say that you have something that weighs 179 pounds, and we see that the weight changes to 178 pounds, then we can see that we had a decrease. And if I do this percent change, so we started at 179 pounds, dropped down to 178 pounds, we have a decrease of 1 pound. And 1 pound, well, it's not certain until we really know what the percent is. Does 1 pound really make a huge difference? Well, I can see that it's not going to make a huge difference out of the 179, right? But we started with 179 pounds, so we're going to divide by 179. And if I do this 1 divided by 179, I get 0.00558, etc. Changing this to a decimal, or from a decimal to a percent, I'm going to move the decimal point 2 to the right. Look at that, it's 0.6%, not even a whole percentage, right? Now let's shift this and say that if we had, I've got this dog, Nibbler. She's the cutest little thing, and she's sleeping here in the chair next to me. But Nibbler only weighs 9 pounds. Now, if Nibbler's weight dropped by a pound, oh, she's awake. She heard me talking about her. If Nibbler's weight dropped by a pound, so if she went from 9 down to 8 pounds, and we calculate her percent change, if I do 1 divided by 9, I see that is a significant change. That's an 11% decrease. So this 0.6% compared to 11%, even though it was still 1 pound difference for both of them, recognizing that with that bigger denominator, if we started out from a much bigger place, so that 1 pound doesn't make nearly as much of a difference as when we start with a much smaller pound to start with. Let's jump in now to some of the examples on the worksheet, now that we have a little bit of an idea of what percent change is used for, and now that we have that formula. If we went from 55 miles an hour up to 70 miles an hour, then to find the percent change, we could do the subtraction. Now I'm going to get a negative number, so you could just disregard that it's negative. So you could even think of it as the absolute value, because it doesn't matter whether it's positive or negative. And then I'm going to divide by the 55. Or if you want to keep it simple, you could just start with the 70 when you do the division. 70 minus 55 and get a positive number. But we get the absolute value, gives us a change of 15. So how much of a change is there? And if you need a reminder of, well, how do I find the change? When you go into the store and you pay with a $20 bill and something costs $17, the way you're going to calculate your change is to subtract, right? So change is always subtraction. But 55 minus 70 is negative 15. And when I do the absolute value, or in other words, just make it positive and divide by the original speed, so 15 divided by 55, I get this decimal 0.27, and that keeps repeating. The 27 just keeps repeating. If I change this to a percent, that's multiplied by 100, or just simply move that decimal 2 to the right, but I'd get 27 0.27 repeating percent. If I wanted to round this to the nearest tenth of a percent, I'm going to look at this 7 to see that the 2 pops up. So we get 27.3%. Do you know what you're doing when you're rounding, by the way? If we were to put each of those two numbers on a number line, the 27.2 or the 27.3, we're trying to see where this 27.27 lands. It lands much closer to the 27.3, doesn't it? Because it's 27.27, closer to the 27.3. Or in other words, 27 is closer to 30 than it is to 20. So when I round it, I'd say it's closer to the 3, so 27.3%. Now when I do question D, 70 miles an hour to 55 miles an hour. Oh wait, is that the same? No, it's not. It's not the same because our denominator is our starting point. So the denominator is going to be 70. And when I do 70 minus 55, I still get the 15. But when I divide by 70, I get 0.2142. So changing that to a percent, I'm going to move the decimal 2 to the right, or in other words, multiply by the 100, and I'd get 21.42%, rounding it to the nearest tenth of a percent, 21.4. So notice that that order does matter because we have to be concerned with which one are we starting with, and we're starting with the 70, so the 70 is what goes into the denominator. So wherever you're starting, that's what goes into the denominator for the original amount. As I scroll through a few more examples, this 92 pounds up to 200 pounds, I'll do 92 minus 200 and divide by 92. Ignore the positive or negativeness. And as I work those out, 92 minus 200 divided by 92, that's a pretty big increase, right? It's more than 100%. We've more than doubled. We've more than doubled from 92. And I'd get 117.39, so 117, and then rounding it, 117.4%. And 18.7 minus 4.5 gives me 14.2 divided by 18.7. I get 75.9% when I round. 75.9% when I round. Good idea to always box our answers, by the way. And 4.72 minus 3.15 dividing by 4.72, I'm getting 0.3326. So rounding to the nearest tenth of a percent, that 2 is going to go up because the 6 is greater than 5. So 33.3%. And let me go back now to this one that I skipped, 5 feet 1 inch up to 5 feet 6 inches. When I've got this unit that's mixing feet and inches, what I've got to do first, I've got to multiply that 5 feet by 12 inches so that I can convert this fully to inches. Or I could convert it to feet, but I'm going to have a decimal or a fraction, so it's easier to convert to the smaller unit, to inches. 5 times 12 is 60. 60 plus 1 is 61 inches. 5 times 12 is 60. 60 plus 6 is 66 inches. And now when I do the percent change, the difference between 66 and 61 is 5. And the original was the smaller, the 5 feet 1 inch. So the 61 inch, when I divide that 5 divided by 61, I'm going to get 8.2%, an 8.2% change. Let's try a couple other examples. If I have seen that the adding cheese, the McDonald's Quarter Pounder, increases the fat content from 21 grams of fat up to 30 grams of fat. I can find the difference from 21 to 30. So I'm going to put the bigger one first, the 30 minus the 21, so that I don't have to bother with negatives. And that gives me a 9, and 9 divided by 21 gives me 42.9% change. Wow, that's a significant increase, isn't it? 42.9%. It's almost half the amount of an increase. So half of the 21 grams would have been 10 grams. And if I added 10, I'd get close to that 30. So you can see that it's almost a 50% increase. And in 10 years, the average number of hours of TV per week actually went down. So if I do the subtraction, 23.9 minus 21.4, and divide by the starting point, the 23.9, then I'm going to get percent increase of 10.5%. Now this next one's a little bit more involved. We've got Bert and Ernie. Interesting, where do you think Bert and Ernie are coming from if they're receiving weekly salaries? So they've got a weekly salary of $520. So Bert has a weekly salary that increases from $520 up to $570. So I'm going to start with the higher number. But remember that the starting point was the $520. So when I subtract, I'm going to do $570 minus $520, just so I don't have to mess with the negative. But if you did the $520 minus $570, that'd be okay. Also, just ignore the negative. So it looks like his raise is $50. And if I divide that 50 by his starting salary, the $520, I can see that he has an increase of 9.6%. And then Ernie, on the other hand, his salary went from $580 up to $645. So he started higher. And let's see where his percentage increase goes. So 580 minus 645, that gives me a negative, but I'm going to ignore that. And then divide by 580. It looks like his increase is 11.2%. So it looks like Ernie had a higher percent increase. Interesting to think of where this Bert and Ernie came from. You might be thinking, oh, that's easy, that's Sesame Street. But have you ever noticed that Bert and Ernie made an appearance far before Sesame Street in the Christmas movie with the It's a Wonderful Life movie? That, look, next time you watch that movie, listen and watch for the Bert and Ernie, and you'll maybe find them. But let's keep going through the examples. Mr. Buckle bought 100 shares of Abacus Core stock, and it went down. He bought it at $36.75 and sold them at $34.50. Not how you're supposed to do it. But what is his percent decrease? So we went 36.75 minus 34.5. And then we're going to divide by where he started, the 36.75. Try that. In order to get more light into a room, Mr. Lumen replaced a 3x5 window with a 5x6 window. So what is the percent of increase in the area? So notice that we've got to find the area first. 3 times 5 would give us 15 square inches. And 5 by 6 window, 5 times 6 is 30, so a 30 square inches window. So I can see right off the bat here that we went from 15 and we up to 30, or oh, I think I just wrote this wrong, didn't I? Because it was a 4, because I know that wasn't supposed to be double. So I apologize for that. Do you see the mistake I made here? I just copied it incorrectly. That should have been a 4. Good reason to use a pencil, right? So you can erase. But 3 times 4 is 12 inches squared. And we increase from 12 inches up to 30 inches. And then we're going to divide by the 12. And then after you divide by 12, ignore the negative for this percent increase. And when we divide, we'll see that we get a 1.5, which translates when we multiply by 100 or move the decimal to the right, that's 150% increase. For question S, if population increased from 2.3 up to 6.1, then when I find the difference, now which one did we start with? For this one, we see it's from 2.3. So the 2.3 is going to go in the denominator, divide that, and you'll be able to get the percent increase. For question T, we have a price for the pair of running shoes was marked down. So we're going to subtract 89.95 minus 75 and divide by the original price, the starting price, and that's going to give us the percent discount. Barbara was earning $8.70 when she got a 6% increase in pay. This one's a little bit different, so let's work this one out. $8.70 is where we started. And if we take her what is her increased pay, what is her new pay, and we divide by her starting pay, we should get 6%, so 0.06. So you could solve this by solving this equation. Actually, I made a quick switch. I forgot that when we're doing this as an equation, we do want to be mindful of getting a positive number. So I'm going to have to put the x first because we know it's an increase. Problem alerts us that this is an increase. So I know that her new pay, so if I let x equal new pay, I know that that new pay is going to be higher, so I'm going to put the new pay first. The new pay minus her old pay will give us the increase amount, the amount of change. When I divide that by 8.70, $8.70, I should get 6%, or 0.06. To solve this, I could think of it as a proportion over 1. And so cross multiply 8.70 times 0.06, and that's going to give me 0.522. And then if I add the 870 to both sides, I can see that her new pay is $9.222, and I'd round that to $9.22 raise. That's one way we could solve this. Let me show you another approach, not using the percent change, but using what we've done in some previous examples. 6% of the $8.70. If I want to calculate how much of a raise did she get, how much of an increase is there, 6% of 8.70, 0.06 times 8.70 gives me 0.522. And if I round that to the nearest cent, I can see that the raise is 52 cents. And if her starting pay was $8.70, then when I add the raise, then I get the same $9.22 as her new rate of pay. Could I show you one other way? And this is what I would say is the best way, the one step. Instead of multiplying by 6%, if I recognize that the new pay is going to be 100% of her old pay plus 6% of her old pay, so a total of 106% of 870, try that and you'll see that you get the answer just from that one step. So if you multiply those, you get the 9.222 and round it to $9.22. So there's a few different approaches for finding Barbara's new rate of pay. One last example here. We want to look at the chart. We can see that we have an increase in crime, and what we want to do is use this chart to find the percent of change, or actually this was a decrease in crime, isn't it? But we want to use the chart to find the decrease or the change in crimes from year 1 to year 5. So in year 1, I'm going to estimate that it to be 23 crimes. And then in year 5, I'm going to estimate that to be 9 from the chart. And if I divide that by 23, from 23 down to 9, I could see that there is a decrease, significant decrease. But I'll leave the calculation for you to do the subtraction and then dividing and then rounding. Well, I hope that this video has helped you have a better understanding of the percent change, whether it's an increase or a decrease, how to calculate it. You'll want to be very familiar with that formula and be ready to apply that formula. It's a great formula for shopping or for understanding inflation or to understand a raise and other problems as well that are applicable to just daily life. So I hope that you found this set of examples helpful, and please reach out to me if you have any other questions.